So this session we are going to study about atomic structure, okay, structure of an atom. So by now probably you must have heard about atoms, molecules. The smallest part is atom. So you have a fairly a very good idea of what is the smallest part, what is matter made up of, okay. You have studied about atoms previously also, but that was not the case when before 1803. Before 1803, people didn't have whether matter is made up of particles, or whether matter is made up of particles, or it was just it was continuously you could divide them, and you can keep on dividing the matter. So nobody had a particular idea. Like for example, at that point of time, even a gas like oxygen or hydrogen containing also had some particles. It was something people couldn't believe it, or people couldn't appreciate that, okay. Now we know even oxygen, hydrogen, any gas we take, it contains molecules, but before 1803 that was not the case. People still believe that, okay, gases means you don't have particles, it is just plain gas, okay, you don't have anything, okay. So that was how people perceived the matter, okay. But the very first experiment was by Dalton. I mean, his observation that when you combine gases, they always get mixed in a fixed proportion, okay. Say for example, 2 volumes of oxygen or 2 volumes of hydrogen always mix with 1 volume of oxygen, okay. Always mix with 1 volume of oxygen to form water, okay. Why is this happening? Okay, if the if hydrogen, oxygen, everything was fluid, or if it didn't have particles, any volume you mix it, you can get water, right? That is the thought process, okay. Dalton questioned this, okay. And at that point of time, we didn't have microscopes, all these things. So then he came up with an hypothesis, okay, probably my atoms are like tiny balls, the matter is made up of tiny balls, okay. And when, like, if these are tiny balls of one, say for example in hydrogen and in water, if this represent hydrogen atoms, okay, and this represent oxygen atoms, so they combine these tiny balls. The matter is made up of tiny balls, each and every element is made up of these tiny balls, and they combined in that. Since they are in the form of tiny balls, when they are combining, they combine in fixed proportion, and they form compounds in exact whole number ratios. So that was his hypothesis, okay. So till that point of time, nobody thought that, okay, there could be an indivisible particle at one point of time. Nobody thought of that. But since this is happening, right, always, why always 2 volumes of hydrogen only combine with 1 volume of oxygen? Why 2 volumes of probably 3 volumes of hydrogen combine with 1 volume of nitrogen, okay. So probably there is something that this atom is made up of balls, and these solid balls, once they are in solid balls, if you want to combine them, they'll have to combine in fixed proportions. That's why his conclusion was, okay, matter must be made up of tiny indivisible balls, solid indivisible balls. So that was how the first concept of atom came about. Okay, for him you cannot divide the atom. Okay, atom is like the once you start cutting down any element, the point you you will reach a point where you cannot divide anything, and that point is that particular particle is called atom. That is what his hypothesis was. Okay, and this experiment, I mean, when this, since gases always mix in a fixed ratio, this experiment proves that. Okay, that I mean, it is not fluid or it is not gas, matter is made up of particles, tiny particles. That experiment proves that. Okay. So, okay, this led to the foundation of complete chemistry. Had this not been done, right, had this not been done, probably you would not have studied chemistry as it is now. Okay. So, this particular thing, then after discovery of this, probably you had discovery of medicines, preparation of medicines. So, when you have medicines getting prepared, how do these medicines get prepared? When one fixed volume of a compound of a molecule or mixes with another fixed molecule, a fixed volume of another molecule. So, when these two combine, you get a new molecule which act as a medicine or something like that. But this discovery, his hypothesis, actually laid foundation to many things in chemistry which you are reading today. Okay. So, so his concept of atom was this: there is nothing inside atom, it is just an atom is a plain solid ball. But in 1897, okay, J.J. Thomson, he was conducting experiments with electricity. Okay, 1897, that was the time when electricity was discovered, and just like ChatGPT or OpenAI is something seen as a very new invention in these days. Everyone likes to tinker that and everyone likes to play with that. At that point of time, playing with electricity was one of the fun activities of the scientists. Okay, seeing let me pass electricity through pen, or let me pass electricity through air, whether it gets passed through air. So they did wide range of experiments with electricity because it was something which was very new at that point of time. So this person, he created somehow, J.J. Thomson, he created a vacuum inside a tube and tried to pass through current, electricity through that. Okay, this is a very high voltage generator or a battery, very high voltage generator. Okay, normally through vacuum, do you expect current, electricity to flow? No. But something fascinating happened. He started observing color at this point of time, at this end, and he was clueless why is this happening at that point of time. Okay, because because since this is a vacuum and current should not pass through this, even if current is passing through this, current should come through this, come back through this anode. Okay, for the sake of terminology, I will tell you that this is a battery, and in this battery the negative charge is connected to cathode and the positive charge is connected to anode. So if you happen to look at a battery behind your remote or something, it will be something like this. One place is bulge, this is plus, this is minus. Similarly, so the negative part is connected to the negative part is called the cathode and the positive part is the anode. So this person, he observed certain mysterious rays. He called them as cathode rays because they were coming out from cathode. Okay, they were coming out from cathode, so he called them cathode rays. Okay, and what he did was, okay, then he started playing around with those rays. What he did, he started putting certain positive charge or negative charge. If you put a positive charge, this rays, this color came here, okay, the rays went like this, okay. If you put a negative charge here, it went like this, okay. That means, okay, so if you happen to do this experiment, think what conclusion will you draw from this, okay. There was some rays, okay, you put a positive charge, okay, the rays came towards you, the positive charge. You put a negative charge, the rays went against the direction of the negative charge, okay. What would be your conclusion based on this experiment, okay? The conclusion is probably this rays had a charge, okay. So, and that must, since it is getting attracted in the positive direction, that means these rays are negatively charged, okay. So, that, and where did this negative charge come from? Because it was, everything was vacuum inside, where did this negative charge come from, okay. That is the question you need to ask, okay. I mean, everything was vacuum, where did this negative charge come from? So okay, first he concluded, okay, these are negatively charged particles. Now the next question is negatively charged, where did this negative charged particles come from? So probably there were few gas atoms, and these gas atoms disintegrated, okay, and gave and negative particles came out of them. That could be the only explanation, because it is completely sealed. Somewhere from outside negative charge coming, it is not possible. So the only possibility is there is a negative, I mean the gas, there were some gas atoms. In these gas atoms there were some negatively charged particles, and upon passing electricity, these negative charged particles got thrown out from the atoms and they appeared in the form of cathode rays, okay. That is the only possible explanation. So in this experiment, in this experiment, when negatively charged particles came out, what it happened is, this particular statement that atoms are indivisible, this became invalid, okay. With this experiment, he was able to say, Dalton, you are wrong, you are not, atom is not indivisible, it is divisible, because I have just seen some negative particles coming out from atoms, okay. If your theory was true, Dalton, this couldn't have been possible, okay. So that is a very important experiment, and people till then were studying that atoms are indivisible, there is nothing inside atom. It is started believing that, okay, atom has negatively charged particles. But the problem is, the J.J. Thomson saw only negatively charged particles, he did not see any positively charged particles. So what he did was, he said that, okay, this particular model was wrong, because I did my experiment, as per my experiment, the model of atom should be like this. It is in the form of a pudding, okay. The dough part, the red color part which I am drawing, it is positively charged and there are electrons in it, okay. The total charge of electrons and the total charge, the positive charge on the dough part, on the shell part, okay, on this part should be equal, because if they are not equal, atoms will not be electrically neutral. You touch any atom, you will start getting an electric shock or current or something. So he said that there are charges present inside an atom, and the negative charges are fixed in a sphere of positive charge and negative charges can come out, okay. Because he didn't see negative charge, he made this his model of atom was this. So remember, at this point of time everyone's understanding of atom is like through some experiments and hypothesis generated from that experiments, okay. Nobody could really see how an atom actually looked like. Only through some experiments which you have did, you could have generated the I mean a simple hypothesis of how an atom was like, okay. So now we by 1897 we came to understand that this is the new structure of atom. But then Goldstein actually did an experiment that, and the same experimental setup, instead of having a thick plate, he did he put a plate with perforated holes or canals, okay. There he was able to see positive particles also. I mean, he was able to see light discharge here also, and this rays, okay, when you put some negative charge, they were going towards that, and when you put some positive charge, they were coming they were going against that positive charge. That means these were positively charged particles, because it got attracted to negatively charged plate and it got repelled from the positively charged plate, okay, fine. So he concluded that atoms must contain instead of what Dalton suggested, that there were no positively charged particles, only a positive shell and negatively charged particles, but he also saw positively charged particles coming out. That means this shell is not positive, there is definitely a shell, but in shell, as there is a negatively charged particles, similarly there are certain positively charged particles also are there in that shell. That is his hypothesis, and that was his hypothesis, and he the structure of the atom now got changed to this. From a positive shell in negative particles, it has a neutral shell with positive and negatively charged particles, and the number of positively charged particles is equal to the number of negatively charged particles. So, okay, then came the very famous experiment of 1911 by Rutherford, okay. He took a very thin gold foil, I mean very thin gold foil, okay, some 5 to 6 or probably 7 atoms thick, okay, extremely. Then out of curiosity, he bombarded alpha rays into on that. Alpha rays are helium atoms, so he bombarded alpha rays onto that foil. He kept a foil, this is a foil, very thin foil, and then he noted the observations. How did this, what happened to this alpha rays, okay. Now till now your understanding of atom was that it is solid, okay, till now it is solid. So a thin gold foil like this you've taken, okay. What can you expect? You bombard high alpha rays, what can you expect? This should come back, right, because this is solid, this is entire solid, and you bombard alpha rays, it should come back, okay. If atom was indeed solid, all the rays should come back, right. But very few, only out of 100, only 5 rays came back. Every ray passed through the gold foil. Now think, what can be your conclusions on this? What can be your conclusion on this? So again I am saying that there is you are passing through you are sending alpha rays, now till now what Goldstein and Thomson have said is atoms are solid spheres. If atoms are indeed solid spheres, okay, everything should come back, all the rays should come back, right, okay, but only 5% rays deflected, only very few 1% or less than 1% rays came back, okay. That baffled Rutherford, like this, that means this is definitely, okay, one possible conclusion can be like wherever the rays went, okay, they must have torn the foil and the rays must have gone to, but the foil was intact, okay. All the rays were going in, all the rays passed through, okay. This detector was able to detect all the rays, okay. One possible conclusion was whenever the rays were going, it pierced this sheet and went, okay, but that didn't happen, okay. The foil was completely intact, okay. That means that made there is only Rutherford conclude that there is only one possibility in that case, that it is possible that most of the space in an atom is empty, okay. So if you take an atom, this is nucleus, okay, sorry, this entire thing is empty, that is his first conclusion, okay. The second conclusion, okay, very small fraction of particles deflected, okay. Deflected in the sense, how can okay, if something is getting deflected like this, that means a negatively charged a positively charged particle, okay, helium plus is positively charged, okay. A positively charged particle, alpha rays are helium atoms, so alpha rays are always positively charged. So positively charged particle gets deflected when it encounters a positive charge, okay. That means there is some concentrated positive charge within the atoms, that is the second conclusion, okay. Very few, less than 5% of the rays got deflected, that means there is a concentration of positive charge, okay. Why did he conclude that it is a concentration of positive charge? Had it been negative charge, right, had it been negative charge, these particles would have stuck there, I mean, okay, you are sent, if there is a positive charge coming and there is a negative charge here, the positive particle will stick to the negative particle and it will stay there, but it didn't happen. So that means there is a positive charge, okay, this is a positive charge hates positive charge, as it went, okay, I don't want to go near a positive charge, so it went like this. So these deflections concluded that there is at one point of time, at one particular place, there is a concentration of positive charge, okay, and that particular place he called it as nucleus, okay. Most of the space is empty, and at one particular place, after this, the second observation led him to conclude that most the positive charge is concentrated at the center, okay, because few rays deflected. Now very few rays, okay, that is 1 in 20,000 bounce back. That means the mass of the atom, the crux of the atom, like the whole solid part, it is located, like it is very small, like this will be the in actually, like if the nucleus, the size of the nucleus will be as small as a grasshopper in a baseball field, okay, in a baseball court, okay, that much small. That only explains that out of 20,000 rays, only one ray came back. I expected all the rays to come back, but only one ray came back, exactly 180, okay. It went like this and it came like this. That means the size of the nucleus is very small, okay. If you take a baseball court to be the size of an atom, the nucleus will be the size of the grasshopper sitting in it, okay. So now we came to the Rutherford's model of atom, in which he is saying that okay, all the positive charge is located at the center, the electrons revolve in orbits, and most of the atoms space is empty. Okay. Then came Mr. Bohr. Okay. When some atoms are heated, right, they give off lights in various colors. Okay. Why is that happening? Why is that happening? I mean, Rutherford's model couldn't explain that. Okay. This particular, then Niels Bohr, this particular experiment made him conclude that probably electrons were revolving in orbits. Electrons were revolving in orbits, and when electron jump from one orbit to another orbit, it could send light. Okay, it could generate light of different colors. So that's why he said that there is a slight modification of Rutherford's model. Instead of only having one orbit, you have multiple orbits. Electrons will be revolving in multiple orbits. Okay. So yes, that's how our understanding of an atom has progressed over years. Okay. From a plain, before Dalton, it was, people didn't even understand whether it was a fluid thing or it was a gas, or whether matter existed in small molecules or something like that. But Dalton's theory laid the foundation. Then we understood, then came J.J. Thomson's experiment, then we topped that with Goldstein experiment, where we understood that there are positive particles as well. Then till Goldstein's and J.J. Thomson's experiment, we thought that atom was atom had a solid shell. But Rutherford proved that no, atoms more than 95%, more than 99% of the space of atom is empty. Okay. Then that was a very big leap in how we understand the present structure of atom. And then finally we had Mr. Bohr, he said that instead of one orbit, you have multiple orbits. Okay. Thank you.